Hey everybody, this is Mr. Wakefield again. Let's take a look at our second worksheet packet. That's where we are at right now in our discussion. And we're going to flip over to section 5.1 today. Actually, this is my, that's my answer key. Let me get in the clean one here. There we go. And let's flip to section 5.1. There we go. As you can see here, we mentioned something that we've already talked about, but we're just going to get into it in a little bit more heavy detail here in this section. Introduction to polynomials, okay? We talked about polynomials back in, and I'm going to put it right above it here, back in your first worksheet packet, very first day of class, very first section, we had this discussion where we talked about what monomials were and what polynomials were. We need to talk about that again here. Monomials could be, instead of just giving you a formal definition, what I did on the first day, and I'll do the same thing here, is I will just give you some examples of what they are. A monomial is either a constant number, okay, or it's a constant number times a variable with a whole number power, whole numbers being 0, 1, 2, 3, 4, those kinds of things. Or it could be an additional a variable as well, as long as that one's also being multiplied. You can see it says times y to the third. So all of these things are monomials, even though they got some of them got a lot of parts to them. They're all still one single monomial, and that's mainly because of the multiplication. Okay, the multiplication between constants and variables does not break it up into multiple terms. Okay, what does break it up is when you have an addition or subtraction symbol in between terms. That's what makes it multiple terms. And so this, for example, would be 2 terms then. This would be 3 because the pluses and minuses, the addition and subtraction, breaks it up into multiple terms. And so, again, our coefficients, we talked about that. It's usually that constant number that's in the front of the term. Okay. And then the degree is the exponent. That's why this one right here is 2. Okay, because it's going to be the exponent. If you have more than one variable, then you add up the exponents. We'll see a lot of those in this section. And then if you have no variable at all, the degree is 0. This one right here, even though you don't see the exponent, you know that x is the same thing as x to the first. So we're going to say that the degree is 1 there since the exponent is 1. Okay. What we're going to do down here is we're going to do something similar as we get into the 5.1 worksheet here. Okay, so it says list the terms of the following polynomial along with their coefficients and degrees. Okay. And so let's go ahead and do that. The terms are what? Okay, terms of a polynomial, again, are the things that they're monomials, like we just defined them a second ago, but they're the things that are being added and subtracted, okay? And if they are being subtracted, then the negative sign is a part of the term. So the terms here would be 12x to the 4th y. And this one, the second one, is not just 5. It's negative 5, x3, y7. The third one is negative x squared, and then the last one is 4. So if you've got terms being added and subtracted, okay, then to form a polynomial, then when they're being subtracted, the minus part is a part of the term. Okay, because this is the same thing as plus negative 5 x3 y7. And it's whatever's being added that is the term. So since this is plus negative, you have to include the negative because it's whatever's being added, and that is your term. And plus, there's a negative that's being added there. Okay, and so that's why that's going to be negative 5, and then down here. By the way, what is the coefficient here as I go on into the next part here? It says also list out the coefficients. Remember when there's no visible constant number in the front of the term there, then that means there's an invisible 1 there. And so that coefficient is going to be actually -1 because of the minus sign. Okay, but when there's no visible number in front of the variable, that means that there's an invisible 1 there. The other coefficients are 12, -5, and when you have no variables at all, the whole thing is just the coefficient. So, but again, the coefficient is by definition the constant number that's being multiplied by the variable part of the term. It's usually in the front. Okay, and if there is no variable, then your coefficient is that entire term. The degrees are what? Okay, again, as we just talked about a few minutes ago, the degrees, if you have just one variable, the degree is just simply the exponent. As we mentioned also a few minutes ago, if there's more than one variable in your term, and you can see this is all one term because the coefficient and each variable, they're all being multiplied here. So that degree is 10 because remember when you have more than one variable, you got to add up the exponents to figure out the degree. And then this one right here, 4 plus 1, remember there's an invisible 1 with the y here. And so 4 plus 1 gives me the degree of that. That would be 5. And then also, as we mentioned a few minutes ago, the degree of a term that doesn't have a variable would be 0. Okay. And so one other thing I want to mention here as we get into more things here is that the degree of an entire polynomial, okay, as you see up here, the degree of an entire polynomial, it's not the same thing as the degree of a term, but the reason why they use that same word, degree, is because it's very closely related. Okay, I know they didn't ask this here, but we do need to be aware of it for later. The degree of the entire polynomial, let's write that down here, is equal to the highest degree of any of the terms. Okay, and so what is the highest degree of all of these terms here, of all these four different terms here? It is, as you can see here, it is 10. And so the degree of the polynomial is then equal to 10 then. Okay, just an additional thing to be aware of there that we'll be talking about a little bit moving forward. But we did answer the questions though. We listed out the terms, the coefficients, and the degrees. One additional thing here, pardon me, not one additional thing, we got a lot of things here that we need to talk about, and that is the how to add and subtract polynomials. Okay, adding and subtracting polynomials has to do with when you have a bracket. See how we got a bracket right here, and then we got another bracket right here, and then there's a plus in between it. Let me zoom in there a little bit for you so you can see that better. Okay, and let me reposition it here. There we go. All right, so you can see here in this problem here that we got a bracket plus in between the brackets, and then a bracket minus a bracket over here. Those are similar, but there's definitely one big difference. So what we do when we have a bracket plus a bracket right here is that we just simply combine like terms. Okay, remember like terms are when the terms have the same variable and exponent matching up. Okay, so as you can see here, the term with the 10 and the -16, they are like terms. So we can combine those together by adding the coefficients, 10 plus -16, and we get -6 x4 y2. All right, and then as we've seen in the past, when we combine like terms, we're going to add our results together, our different results that we get. And so let's keep that in mind as we go forward here. Notice that this term right here, and also this one right here, these two right here, those do not have any like term partners, okay? They don't have anybody to combine with. And so what we do when we combine like terms and we have some terms that don't combine is we just bring them down and we add them to what's already there. So we'll add negative 3x squared y squared, which is the same thing as subtracting 3x squared y squared. And then we'll also add negative 4x to the third y, or pardon me, x squared y. Okay, right there. And so that gives me these two right here. And then finally, we have these two terms here. Okay, those do combine, don't they? Right? And so remember, this coefficient is negative 1. Negative 1. And so 2 plus negative 1, which is the same thing as 2 minus 1, is going to be positive 1. How do we write that? Okay, remember, we got to add our results. So since it's positive 1, we could say either 1xy, you guys. But since 1 can be invisible, if it's a coefficient, we can just say xy. You could say it either way. You could say 1xy, or you could just say xy. But since we're adding our results together, remember to put that plus there, okay? Because we're adding our results together here. And so that's our answer right there. Okay, so the difference between problem B and problem C, you guys, is that when you have bracket minus bracket, the key thing there is the minus. What we do is we take the second bracket right there, and we need to change the signs of every term in that bracket, not just the first term, but all of them. But we need to do that before we combine like terms, okay? And so let's talk about that. Okay, it's kind of like the reason why we do that, by the way, is that back when you first learned about subtraction, like for example, if you did 8 minus 12 back in the when you were a younger math student, it's the same thing. When you have a number minus a number, that's the same thing as keeping the first number the same and then changing the sign of the second number while simultaneously changing this from subtraction to addition. Same exact thing happens here, only it happens not with numbers but with brackets. The first bracket stays the same, just like the 8 did. So let's bring that down. First bracket stays the same. And then the second bracket changes its signs, all of it, because of the fact you're subtracting the entire bracket when it says bracket minus bracket. That's why you got to change the signs of everything in there, not just the negative 16, but everything. So wherever you see a negative, change it to a plus. Wherever you see a plus, change it to a minus. Okay. And so we get this right here. Okay, you can see how the minus, the plus, and the minus became plus, minus, plus. Okay, everything changed. Then simultaneously at the same time, just like it was up here with this problem, the minus that's in between the brackets changes to a plus like that. Okay, and this is significant because now you can realize that this problem now looks just like the last problem. Okay, where in other words, we transformed it into a problem that looks just like the last problem. It is now a bracket plus bracket problem. Okay, and so we can now do the same thing we did over here, since it's now the same thing, bracket plus bracket. What did we do over here, you guys? We combined like terms. Okay, now I notice here as I'm combining like terms, and what we usually do, you don't always have to do this. I'll tell you when you need to, but usually we put it in descending order of degree, meaning we start out with the highest degree term first, and then we work our way down to the lowest one. And so see how this is the highest degree term right here in the entire thing. And so we're going to do that one first, but that one doesn't have a partner to combine with. And so again, we just bring that down, right? Okay. We're not adding it to anything that's already there like we did in the last problem when we had terms like that. So we just bring it down. Okay. And then we go from there. Now this, what's the next highest degree term? It's actually this one and this one right here, right? Okay, those two are degree 5, and they do combine with each other. So negative 5 plus 16 is going to be 11 x3y2. Again, the variable part of the term stays the same since we're combining like terms. But because it's positive 11, we got to remember to put that plus there since we are adding our results together when we combine like terms. And I just noticed here I have a little bit of a misprint here. This should say x. This should say xy2. Just straight from up here, I accidentally wrote down the 3 there. But that's also going to be important here because these two terms are like terms, but they're going to cancel out, aren't they? They're going to be equal to 0xy squared. But 0 times anything is just 0. And since we are adding our results together, if you add 0, you don't need to write that, do you? It's kind of like saying that 8 plus 0 is the same thing as just 8 only. Okay? So when you add 0, you don't need to write it. And that's the reason why when two terms equal 0, when you combine them, we oftentimes say that they cancel each other out. You've probably heard that phrase before, and we've talked about that in past worksheets. And so those cancel out. And then that just brings us to one term left here, 7xy. It doesn't have a partner, so we just add that to what's already there. Okay, and we have combined all the like terms that we can. Okay, and we brought down anything that didn't combine. That's what it means to combine like terms. Okay, what I'd like you to do right now, like normal, is to take these two problems right here, 1 and 2, try them yourselves. Go ahead and please hit the pause button on your video, and then we will go ahead and take a look at those answers here in just a moment. And when you're done with problems 1 and 2, just hit your play button, and we'll take a look at the answers. Go ahead and take a look at those answers here. So in number 1, we had what? We have, again, a bracket plus a bracket, don't we? Okay, let me move this up here for you. A bracket plus a bracket, and so that means that we just combine like terms, all right? There's no sign changing going on. If we do that, we get 13x squared, right, on the first two terms there, right? Okay, and then these two terms also combine, and that gives me what? Negative 6 plus 2 is going to give me negative 4x. And that's all that we got there. We accounted for every single term, all right? We combined the like terms, and then there was nothing additional besides those terms being combined, so we accounted for every term there. Okay, that's what it means to combine like terms. Combine what you can, and then whatever doesn't combine, you just bring that down like we've been doing. In number 2, we need to do what? We need to, when we have a bracket minus a bracket, we first of all need to change the minus to a plus, correct? Okay, and but at the same time, we need to change the signs of every single term in that second bracket that's being subtracted. Now notice that this is a positive 3, so that needs to change to a negative 3, okay? And then the rest also change, minus to plus, plus to minus, minus to plus. And that now, and you can see I use my arrow here, that now means that bracket plus bracket is what we have, and so now it's just like this problem. In other words, bracket plus bracket means that we now need to combine like terms on the next step. So we'll do that. So 5 and negative 3, those two terms combined, since they're like terms, that gives me 2x to the 4th y squared, as you can see there. What else combines here? How about the 6 and the 5 right here? Those combine, and that gives me positive 11. So remember to put your plus there if it's positive, because we're adding our results. Now, these next 3 terms that we haven't done yet, these terms all have the same degree. So you might be wondering, oh, what order do I need to put it in? Since they're the same degree and we're supposed to put it, go from highest degree to lowest degree. It doesn't matter when they're the same degree normally. I'll let you know if it does matter at some point, but it usually doesn't. So you can go ahead and do the y's first and then the x's, or vice versa. What did I write down here? I did the y's first. So the y and the y here, the negative 7 plus 6 is going to be negative 1y, and that's why I wrote down negative y right there. Remember, that's the same thing. If you have a coefficient that's equal to 1 or negative 1, you don't need to write the 1, but you do need to write the minus if it's negative 1, okay? And then the last thing there is the 8x. That does not have a partner, so we need to account for him and bring him down as well and add him to what's already there. And so now we've taken care of all of the terms. Okay. All right, so that completes section 5.1. Again, contact me if you have any questions about any of this.